Have you ever wondered what the universe is made of? As we journey through our daily lives, we often overlook the profound intricacies of the world around us. The air we breathe, the water we drink, the ground beneath our feet, and even the stars that twinkle in the night sky. All are composed of elements. These elements, from hydrogen to uranium, are the building blocks of matter, the foundation of everything we see, touch, and experience. Yet have you ever stopped to ponder where these elements come from? How did they come to be scattered across the vast expanse of the universe? The answer is as awe-inspiring as it is complex. The elements that make up our world, our bodies, and the cosmos beyond are not born on Earth. No, they are created under the most extreme conditions imaginable, in the heart of stars. The universe, in all its vast complexity, is largely composed of elements that are created in the heart of stars. To understand where these elements come from, we must first look to the birth of stars. Our journey begins in the cold, vast expanse of the cosmos, where floating clouds of gas and dust, known as nebulae, slowly dance in the nothingness. These nebulae are the cradles of the stars, the celestial nurseries where the magic of stellar life starts to unfold. Gravity, the invisible puppeteer of the universe, starts to play its part. It pulls together these particles of gas and dust like an artist gathering materials for a new masterpiece. As these particles draw closer, they form clumps, growing larger and denser over time. This process is not a swift one, but patience is a virtue, even for the universe. As these clumps grow larger, pressure and heat start to build up within their core. Think of it as a celestial pressure cooker where the ingredients are gas and dust, and the final dish is a star. The pressure and heat continue to rise until they reach a critical point, a threshold where something wonderful happens. This is where the magic really starts. The intense pressure and heat spark nuclear reactions within the core of these clumps. This is nuclear fusion, a process where atomic nuclei combine to form heavier elements. And voila, a star is born, shining brightly, a beacon in the vast cosmic ocean. But the birth of a star is just the beginning. The real magic happens deep within the star, in the heart of these nuclear reactions. Here, under extreme conditions, atoms are fused together, creating heavier elements. This nuclear fusion, this dance of atoms under immense heat and pressure, is not just the birth of a star, but the birth of the universe's elements as well. These nuclear reactions, happening deep within stars, are the factories where the universe's elements are made. The birth of stars is not just a cosmic spectacle, but a process that shapes the very fabric of the universe. A process that creates the elements that make up everything we know, from the air we breathe to the ground we walk on. Now, what exactly is this process of nuclear synthesis in stars that we're talking about? Well, let's break it down. Nuclear synthesis is the process of creating new atomic nuclei from pre-existing protons and neutrons. And where does this happen? In the heart of stars, where temperatures reach millions of degrees and pressure is incredibly high. So what's going on in there? Essentially, it's a cosmic kitchen where the most basic element, hydrogen, is cooked into a slightly more complex one, helium. This transformation isn't as simple as a stovetop recipe, though. It's powered by a process known as nuclear fusion. Imagine billions and billions of hydrogen atoms, each consisting of one proton, zipping around at incredible speeds due to the extreme heat. When two of these atoms collide with enough force, they can overcome their natural repulsion. Remember, like charges repel each other. They fuse together, forming a heavier atom, a helium atom. But the mass of the helium atom is slightly less than the combined mass of the two hydrogen atoms that created it. Now, you might be thinking, where did that lost mass go? It didn't just disappear. According to Einstein's famous equation, E=mc², mass can be converted into energy. That tiny bit of lost mass gets transformed into a tremendous amount of energy, which is emitted as light and heat. That's why stars shine. But wait, there's more to it. Sometimes, under extreme conditions, helium atoms can further fuse to form even heavier elements like carbon, oxygen, and so on. This process continues, creating an array of elements up to iron. This process of fusion, or nuclear synthesis, is not only responsible for the energy stars emit, but also for the creation of new elements. So, the next time you gaze up at the night sky, remember that you're seeing a cosmic kitchen at work, cooking up the elements that make up our world. So, how does this fusion process lead to the creation of new elements? Well, let's dive right in. Stars are veritable element factories. They start off with a core composed primarily of hydrogen atoms. As the star matures and heats up, these hydrogen atoms begin to move faster and faster, eventually reaching speeds so high that they overcome their natural repulsion for each other. When this happens, they collide and fuse together, creating helium. This is the first step in a process known as stellar nucleosynthesis. But stars aren't content with just producing helium. As they age and their core temperatures rise, they begin to fuse these helium atoms together, creating heavier elements like carbon and oxygen. This process continues, with each successive generation of fusion reactions producing heavier and heavier elements. Imagine a star as a kind of cosmic kitchen where light elements are the ingredients and heavier elements are the end products. In the searing heat and pressure of the star's core, helium is cooked into carbon, carbon into neon, neon into oxygen, and so on, all the way up to iron. But why stop at iron? Well, the fusion of elements lighter than iron releases energy, which is what keeps the star shining. However, the fusion of elements heavier than iron absorbs energy instead of releasing it. This creates an energy deficit, which the star can't sustain. So, it stops at iron. But don't worry, the universe isn't deprived of elements heavier than iron. These are created in the explosive death throes of massive stars or supernovae. In these cataclysmic events, the conditions are just right for the creation of heavier elements, from cobalt all the way up to uranium. And there you have it. From humble hydrogen to complex uranium, stars are the architects of the periodic table. They create these elements over their lifetime, and when they die, they scatter their elemental riches across the cosmos, seeding future stars, planets, and even life itself. The stars, through their life and death, scatter these elements across the universe. These processes happening in stars are the reason we have a universe filled with diverse elements. Now let's delve into how stars play a pivotal role in populating our universe with a myriad of elements. You see, stars are not just celestial bodies that twinkle in the night sky, but rather they are cosmic factories, tirelessly working to create and disperse elements across the vast expanse of the universe. Every star goes through a life cycle, much like living organisms on Earth. They are born, they live, and eventually, they die. However, unlike most organisms, the death of a star is a spectacularly violent event known as a supernova. This explosive end is not just a spectacle to behold, but it's also a crucial part of the process of creating and distributing elements. When a star explodes in a supernova, it doesn't just fade away into nothingness. Instead, it scatters the elements it has spent its lifetime creating out into the cosmos. This celestial explosion seeds the universe with elements from the lightest hydrogen to the heaviest uranium. These elements, thrown out into the universe, become the building blocks for future stars and planets. They form nebulas, vast clouds of gas and dust, which over millions of years collapse under gravity to form new stars and planetary systems. And it's not just on a cosmic scale that these elements matter. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were once part of a star that exploded. It's a humbling thought, isn't it? We are quite literally made of star stuff. The abundance of elements in the universe is a testament to the countless stars that have lived and died, contributing to the cosmic cycle of birth, death, and rebirth. The elements they create and the way they scatter them across the universe are all part of the intricate tapestry of existence. So next time you look up at the stars, remember that you're not just seeing balls of gas and light, but the cosmic factories that have created the universe as we know it.